It is given that y of n is a function and y of minus 1 is 5 whereas y of 1 is 8. We have to find dy by dx at a point x is equal to 0 as per Newton's central difference scheme. Now we know that Newton's central difference scheme, that is dy by dx at x is equal to 0, is nothing but ratio of difference of y coordinates to ratio of difference of x coordinates, which is nothing but y2 minus y1 by x2 minus x1, which is y of 1 minus y of minus 1 by 1 minus of minus 1. That is nothing but substitute the values 8 minus 5 by 1 minus of minus 1. That is nothing but 3 by 2, which is 1.5, option B. X square minus 2 equal to 0 by using Newton-Raphson technique, whereas x naught is given as 1 and we have to find x1. Now look here, f of x naught will be nothing but x naught square minus 2, which is 1 square minus 2, which is nothing but minus 1. Similarly, let us find f dash of x naught. F dash of x naught is nothing but 2 of x naught, which is equals to 2 of 1, that will be 2. Now x1 is nothing but x naught minus f of x naught by f dash of x naught according to Newton-Raphson method. If I substitute the values, it will be 1 minus of minus half, which is 3 by 2. Answer is 1.5, option B. That a product has 0.5% defective pieces. Now all these pieces are packed in cartons of 100. Now we have to find the probability that they do not have more than 3 defective pieces. Now the probability of defective pieces is nothing but 0.5%, which is 0.005. Now what will be the probability of non-defective pieces? 1 minus this value. That is nothing but 0.995. Now we need probability that not more than 3. That means less than or equal to 3. So it should be less than or equal to 3. No. Now what is it saying is we need the probability that they do not have more than 3 defective pieces. So it can be 3 or less than 3. So it may be either 0, no defective pieces, or it could be either 1 defective piece, or it could be either 2 defective pieces, or it could be either 3 defective pieces. Now let us use the formula here. So n is nothing but 100. C0 0.995 is nothing but the probability of getting a non-defective piece per 100. Similarly 100 C1 into 0.005 into 0.995 raised to the power of 99. Similarly the next term will be 100 C2 into 0.005 square 598 plus 100 C3 0.005 cube into 0.99597. If you simplify this entire expression, it will be 0.9983. So the required percentage is 99.83, which is nothing but option A. Z1, Z2, Z3 and Z4 form a parallelogram. So that is Z1, Z2, Z3 and Z4 in a complex plane. Now we know that in a parallelogram diagonals bisect each other. So Z1 plus Z3 by 2 must be equals to Z2 plus Z4 by 2. That implies Z1 plus Z3 must be always equals to Z2 plus Z4. So the answer is option C. No boundary conditions for the differential equation dou square 5 by dou x square plus dou square 5 by dou y square equal to 0. Now it is clearly a second order differential equation. So the number of boundary conditions required are 2. That is option A.
K2 is equal to 2K1. Original one will be the stiffness of the spring when compared to the original one will be now the present stiffness K2 when compared with the original spring is going to be twice than that of the original spring stiffness coefficient. So option A is correct. Question: when the beam is subjected to a bending, then the bending moment produced in the beam is 150 kilonewton per meter is given. Bending moment produced is 150 kilonewton meter, that is 150 into 10 to the power of 6 newton millimeter. As the options are in terms of millimeter, so we convert in terms of all into a single unit. Find the sectional modulus of the beam when the beam stress developed is bending stress developed is 100 MPa. 100 MPa is nothing but 100 Newton per millimeter square, right? So the sectional modulus M by FB, we know 150 into 10 to the power of 6 divided by 100, that is equal to 15 into 10 to the power of 5 millimeter cube. Sorry, this option is 15 into 10 to the power of 5. So option A is correct. Question is, determine the number of redundant unknowns or degree of static indeterminacy, we can say, of truss structure as shown in the figure. So in this figure, the members we can count it as 6 and the nodes is given as 4 and the components of support reactions is equal to 4 because of these two supports. So we can find out NR, number of redundant unknowns of the structure, NR, or degree of static indeterminacy, is equal to 6 into 1 plus 4 minus 4 into 2, that is equal to 2, where 1 here 1 is for truss members because it is a truss, so we have used 1. If it is a beam, that has to be 2. For frames it has to be 3, and these 2 for trusses because it is a truss, and 3 for frames. From this we can say the number of redundant unknowns of the structure is 2, or degree of static indeterminacy is 2. So option D is correct. And is, what will be the ratio of maximum twisting moment of a solid and a hollow circular shaft when the maximum shear stress developed is same in both the cases? So by seeing the option, all other things are constant in case of solid and hollow circular shaft, the diameter only is changing. So with respect to twisting moment for a solid circular shaft, we know that pi by 16 sigma max into d cube, whereas in case of hollow circular shaft it is pi by 16 sigma max into d power 4 minus d power 4 by d, whereas d is external, the small d is internal. So consider it as 1, consider it as 2. We have to find out the ratio between solid and hollow. So 1 by 2 is equal to d cube by d power 4 minus d power 4 by d, that is equal to d power 4 by d power 4 minus d small d power 4. So option A is correct.